Hi everyone, my name is Kevin Raj and today I'll be presenting my computer architecture case study. Let's begin with definition of security and protection service. Security in an operating system refers to the mechanism and policies that protect the computer system from unauthorized access, misuse, or damage. Protection ensures that each process and user operates within their assigned limits and cannot interfere with others. Together, they ensure that system resources such as file, memory, CPU, and device are used properly, securely, and efficiently. And now look at for the authentication. Authentication verifies the identity of a user or process before granting access. This can be done by using passwords, biometric scanning, like fingerprint, security tokens, or two-factor authentication. It ensures that only legitimate users enter the system. And now look at for the authorization. Authorization determines what actions or resource an authenticated users can access. For instance, administrators may have full privileges while normal users have limited access. This prevents data misuse and enforces organizational rules. And now look at for the access control policies and privilege management. Access control policies define who can access which resource and what operations they are allowed to perform. Common models and include DAC, DAC, user control their own file permission. For MAC, like mandatory access control, access is decided by system policies and securities labels. For role-based access control, for the short form RBAC, access is based on the user role in the organization. Privilege management ensures that users and processes only have minimum access required to perform their tasks. This reduces risk of exploitation and prevent privilege escalation attacks. For example, a normal user should not be able to install system level software without administrator approval. And now looking for the auditing, monitoring, and backup strategies. Auditing and monitoring help administrators track all activities within the system, log files, instruction detection, system, for example, like IDS, and even monitoring tools help detect suspicious behavior early. Backup strategies ensures that important data can be recovered after system failure or cyber attack. Regular backup, secured and external location protect against ransomware and hardware crashes. And now look at for the network topology for TechNova solution. A presentation is a formal or informal communication method, sorry my bad, that involves conveying information, ideas, or message to an audience. It often employs visual aids such as slides, cards, graph, or multimedia element to support and enhance the spoken content. And now look at for the flow 1. As guys, you can see the terminal is on the left, there is left side. So we can see laptop 1, laptop 2, laptop 3, laptop 4, and lastly is printer. All laptops and the printer are attached to one backboard cable. Everyone can print to the shared printer using the same network, like terminal like 2, like that, right? For the floor 2, on the left side we can see server, which is high spec desktop 1 to desktop 10. And for the printer we have two, like printer 1 and printer 2. As I explained it down, all 10 desktop, 2 printer, and 1 server are connected to a single bus backbone. The server stores code repositories and share project files, while the printers are available to everyone on the floor. Let now look at for the floor 3. as the same left side got terminal, and but for the right side we also got terminal, but on the middle side we can see desktop 1 until desktop 5. Every desktop shares the bus for the data, and printing this keep the layout simple and cost efficient for support and sales operation. And now look at for the instruction set. The instruction set is the collection of operations that a CPU can perform. It defines the interface between software and hardware and includes arithmetic, logic, data movement, and control instruction. For example, in a Motorola 68,000 processor, instruction like move, add, stop, and mulu for MULU lah, are part of the ISA. And now look at for the machine language. Machine language consists of binary code, which is 0 and 1. It cannot up to 0 and 1. That the CPU directly understands. It is lowest level representation of programs. Each instruction in the ISA corresponds to a specific binary pattern. Assembly language. Assembly language is a human readable representation of machine language using mnemonic short text commands. For instance, instead of writing like binary code, for example 1011 and 40 lah, a programmer write move b d0 d1, which is easier to read, so for the programmer like us can understand easily. And for the arithmetic instruction, this perform mathematical operation such as addition, subtraction, multiplication, and division. For example, you can see from down 8 add dot b, I don't know what this hashtag 5 comma d0 adds the number 5 to register with d0. For the mulu w, we can d0 and d1. It is multiplies two unsigned integers. These instructions are used in computation, counters, and numerical algorithms. And for the data transfer, movement, and instruction, this move data between register or between register and memory. For example, move b0 d01, move the bit from d0 to d1. And another one example, move L, which is a0, like d0, move data from memory access, my bad, memory address a0 to d0, my mistake. These instructions are essential for data handling and program control. Let's look at logical instruction. These perform bitwise operation that manipulate binary data. For example, n.b hashtag $3c, d1 performs bitwise and between 3c and the content of d1 or b d0 d1 for another example, which is combined bits using OR operation. And now look at for the EOR d.b hashtag $25 comma d1. For me, I'm saying this for easy to me understand this, which is perform not or operation to toggle specific bits. And now for the logistic instruction are wisely used in testing, condition making bits, and controlling flags. And now look at for the question C lah. Find d1 value after instruction execution below given d0 equals to 000000015, and for the d1 0000055. And now for the question 1, move b d0 to d1 with 8 bit. Before, look at this. Now look at this lah. I have explained this all I had here for d0 000 to 15. Like this lah. And now look at the question 2. add B hashtag 25, which is D1 for the byte bit 8. Before intermediate value D1 equals to 0.0000055, and at the same like this 0.00019, which is calculation show implicitity 55 hexadecimal plus 19 hexadecimal, which is 6E16. And after converting this, then we got 0.00006E. And now look at for the question 3. For the sub B, D0 and D1 byte 8. Before D0 0.0000015, and the same one lah, let's say like same lah, D1 is equal to 0.0000055. And for the node byte bit, just use 2 digits before after that. Look at this, 15. Answer 40 result. And now you can convert this into this. For the question 4, Mueller W, which is D0 and D1. Before we can see that the D0 equals to the always are same, but note this, we'll just use for 4 digit at least significant word. And now look at for the answers. 0055 hexa, and now look at for the 0015, that equals to 06F9 hexa. And look at the after answer. So we just convert 015 into 659. And now look at for the fifth question or sixth question. Look at the another question or B, which is D0 and D1. Before we can see all are same, but for after the calculation binary or $50 hexadecimal equals to 0.000010101 binary, which is hexadecimal for 50, and that equals to 01010101 hexa. All are same only, not such a huge difference. Let's look at the last, I think it's last question. EOR.B hexadecimal D1 lah. Look at the hashtag 000000 6 times 0 and 25. Look at the D1 00000055, and look after the calculation binary EOR and minus with exclusive OR, which is 55 lah, hexadecimal 0101010100, all are same, which is, and one more is 25 hexadecimal equals to 00100101 binary, and another one. And thank you for your attention.